How to resolve particles in static equilibrium. Right, so first of all, you've got to have the case where there's a single particle in the middle with forces coming out from that particle. So P, 8 Newton force and a 7 Newton force. It's got to be the case. It can't be anything like a particle like this and then force like that and then force like that, then force like that. Nope, you got to resolve and make forces coming out of that particle like that, like that, like that. It's just got to be coming out of the particle. Coming out of the particle itself. It can't be above the particle, anything like that. I think you know what you mean by now, but yeah. It's just got to be coming out of the particle. So that's the first condition. Second condition, it's got to be 3 forces. Can't be 4, it won't work. Yeah, because it's got to be a triangle. It's got to form a triangle. And yeah, next thing is to draw the triangle. You just look to see which forces. If you put a force in a certain place, will it make a triangle with the other force? You'll see what I mean now, right? So first, draw the first line. 8 newtons. Why not? Now you see this line is coming down like this. It's exactly the same direction. Doesn't really matter the same size because it's not to scale. But now you've drawn the first vector and you're trying to make these 3 vectors line up to look like a triangle. So now if you look, this vector is coming out like that. This vector is going out like that. If I was to draw P first, going out like this. Yeah. And then 7 newtons going out like that. Just form a closed triangle. Formed a closed triangle. And then this was that was a 7 newton. 7 newtons. P newtons. So all I've done here is move the P to there, move the 8 to there, move the 7 to there. So it's exactly the same forces, exactly the same diagram. You just don't include the particle, and you've drawn it as a closed triangle. So now because you've got a triangle, you can work with this triangle if you knew the angles, some of the angles in said triangle. So you got angles here. You got the angle 40 degrees and the angle 35 degrees. So the rule is, if the angle between A and B is theta, the angle in the closed triangle is 180 degrees minus theta. And this is what made it so much easier for me, rather than just spotting angles or some shit, right? So, referring to this, if the angle between A and B is theta, the angle in the closed triangle is 180 degrees minus theta. So, theta is just any angle, but this just happens to be called theta. So, you're looking at the angle between A and B, and in this case, A and B are the vectors, so the vectors of force, so what you call them, A newtons and B newtons. So A in this case is the 7 newtons, the B in this case is the 8 newtons. So you look at the angle between the 7 and the 8, which is this whole angle here. So that's 35. plus 40 plus whatever this is, but it's obviously a right angle because these are at 90 degrees to each other, these two lines, and then this angle is touching the axes, so is this one, so you just add 90. So 35 plus 40 plus 90 equals 165. Yep. So you've got 165 degrees here. This is what this whole angle here is, all of this. So using the rule, the angle between A newtons and B newtons is theta. The angle between, in the closed triangle, 180 degrees minus theta. So theta equals 165 degrees between 7 and 8 Newton force. So in the triangle, between the 7 and 8 Newton force is 180 degrees minus theta, which is 180 minus 165, so this is 15 degrees. Okay, so now, moving on to the next one. So you're trying to find the angle between the 8 newtons and the p newtons. So 8 newtons and p newtons, that's this. So what's this? This plus this. So this is 90, because this is, all this is 90. 90 minus 40, so this is 50. That means this angle is, which one am I referring to now? P and 8. P and 8. So this is theta plus 50. And the angle in here, between the 7 and the P, is this angle here. So now, you got 35 here, the theta here. You know that this angle is 360, take away all of these other angles, because there's 360 degrees in a circle, or 180 minus 35 minus theta, because angles on a straight line are out to 180. So 145 minus theta is this angle here. I'll draw it a bit better now. Right, so now you've got all of these in this triangle. So, what can you do with this triangle now? So you're trying to find P and you're trying to find theta. So, what do you know about this triangle? What rules can you think of? Well, you got the cosine rule and you got the sine rule. So to find P, what could you do? You've got this. You've got two sides with an inside angle, which is the cosine rule. So cos A equals A squared plus B squared minus. Now, A squared, that's wrong. Cos A equals C squared. C squared plus B squared minus A squared all over 2BC. So this is the cosine rule. So cos of this equals this, or you can rearrange it to A squared equals B squared plus C squared minus 2BC cos A. Okay, so now you've got this. You can work out P, because that's A squared. If you label them A, B, C, that's not a C, and then big 8 there. So let's work that out now. A squared equals b squared, so 7 squared plus 8 squared minus 2 times 8 times 7 times cosine of a is 15. So 4.8, 4.81. 6 newtons. So I got this. We're trying to work out these two. So to be honest, you can just work these out by using the sine rule or another rule. You don't really need to know that these are. You don't actually need to use these angles themselves in working out what the whole angle is, because you can just do sine of this over this equals sine of sine of this over this equals sine of sine of this over this equals sine of this over this, but you can just call this whole thing theta. So you actually need to know that this is 145 minus theta, and you can do the same for this one, but it's just doesn't really matter for the context of this, what I'm trying to show you how to do. So yeah, that's how to draw a false triangle with a static particle.